Greetings everyone. For today we're looking at number-based system. And when you talk about number-based system, there are a lot of things that comes into the mind, especially bringing it to mathematics. What concerns number-based with mathematics? Now it is very, very pertinent that we must understand that based on mathematics, we really need to understand number-based system, because it helps us understand the system of counting. Okay, it helps us understand the counting steps or skips of a particular number. Now it's also relevant in terms of, the world is becoming more digital, so we need to also understand how electronics operates. We need to understand how the computer operates. For example, the computer does not understand English language, right? So you need to also understand this concept to be able to understand the machine language. Not that you understand it in totality, but at least having a clue of what a number is. For example, the computer uses zeros and ones, and zeros and ones are represented in number system, which is binary number, right? So when you have this concept, what comes into your mind? Very simple. Now in number system, we have a lot of things we're going to talk about. We have the decimal, which is a number in base 10. Okay, so we do our decimal. Decimal has a number is a number in base 10, which ranges from 0 to 9. So binary decimal contains number between zeros to 9. When you talk about binary, for instance, it contains number between, that is base 2. It is a number in base 2. Binary is a number in base 2, which contains number from 0 to 1. Okay, just these two. Now if you have another one which we call the octal, which contains number between, that is the number in base 8, which contains between 0 to 7. And the common one we have again is the hexadecimal. Hexadecimal, which contains number between, that is the number in base 16, which contains between 0 to F. Now this F has a little structure. Okay, now what happens and how do we get the F? In base 16 we have that once a number passes 9, 0 to 9, right? Once it passes 9, the next number should be 10, 11, 12. But then in number system we don't count 11, we don't have 10, 11, 12. So what do we have? Now the place of 10 becomes A. So this is 10, B, this is 11, C, this is 12, D, D, 13, E, 14, F, 15. So you see A, B, C, D, E, F. Now take note of this. The representation of these numbers must always be in capital. It must always be in capital. So if you think about a number in base 16, you don't have 12 as in number 12, right? You have what? C. That is it. But then you can easily imagine that C is already 12 in real setting, right? In real setting it is 12, 13, 14, 15. But then you don't call it 15, you call it what? F. Okay, except you are being asked. So if you are being asked a question like, for example, let's say how many digits or base 8 contains what digits? Base 8 easily contains, which is octal, contains number between 0 to 7. Base 6 contains number between 0 to 5. Because if you count this number, look at this becomes 0, 1, 2, 3, 4, 5, right? That is it. So if you count it 1, 2, 3, 4, 5, 6. So this is a number in base 6. Okay, it contains number between 0 to 5. Anything can fall within this range. Now next we need to understand in this number system is how do we convert a number from base 10 to any base, and also how do we convert a number from any base to base 10. It's very important that we should understand this. How do you convert a number from base 10 to base 2 or to base 8 or to base 16 or to any other given base? Now, and also how do you convert a number from base 2 or base 8 or base 16 or any other base to base 10? These are the things we're going to learn in this short interval. So if you have, for example, let's see something here. If I am given a number such as or if I'm giving a number such as 1101 base 2. Don't forget, we said that a base 2 is a number in binary, right? And we said that a binary number contains only zeros and ones. There's nothing like 2, 3, 4 in binary. So it means that in binary you cannot see something like 0, 1, 1, 3. No, this is not a binary. You don't call this is not a number in binary. This is not a number in binary because binary contains 0 to 1, not 3. Okay, so how do you convert this number? Let's convert this number from this state in base 2 to base 10. When you're converting any number to base 10, when you're converting from any base, take note, when you're converting from any base to base 10, we have a simple rule which I've already told you guys, which is what? Expansion notation. Expansion notation. Now, how does expansion notation work? Now, in expansion notation, I'm not going to list the steps, but I'm supposed to write it, but then I'm not going to write it because of time. So let's learn together. What do you do in expansion notation? Watch my steps, please. The first thing you need to do in expansion, just that expanding something, spreading something, right? To extend something. So if I'm given a number such as this, you say convert this to base 10. I said the rule or the method you use is what we call what? Expansion notation. Now in expansion notation, what do? You expand the given number. Expand the given number. How do you expand the given number? By multiplying each of the digits of the given number by the base. This is the base. This is the base, base 2, right? By multiplying each of the given number digits of the given number by base 2, the given base. It can be base 3 or any other base. But what you need to do is for you to expand it, do what? Multiply each of the given base, each of the given number or digits by base 2. Okay? Now add them together and also focus on the power. Those are the 3 steps you're going to take. The first thing is to expand it by multiplying each of the number by the given base. So that, let's go, 1 times the base. The first number is this, times the base, plus, add it together, 1 times the base. I'm done with that one. Now this one, plus 0 times the base. I'm done with that one. Now go to this one, plus 1 times the base. So these are the first steps, the first 2 steps you take. The first one is to do what? Multiply each of the given number by the base, okay? And after which you add them together. So you can see that this is given, this is this, this is this, this is this, this is also this. Now the next thing you need to do, some textbooks or some persons will tell you group it into brackets, right? For example, you can do something like this. You can do something like this, okay? But so that you will not be confused. Anyone you want to master, you can do away with the brackets, but know what you're doing. This one becomes, start from the right hand side, from the extreme right. Put what we call index number. Index number simply means power, the power of, okay? So you start from 0 and label, start from the last number by the far right, okay? And label the power to be what? From 0, 1, 2, 3. You are only labeling the base, okay? Take note, you are only labeling the bases, not the digits given, okay? Not the whole number given. So you don't label this. That is the mistake some persons make. And also you don't write your powers here. This is very, very wrong. This is very, very wrong. If you write the power on the bracket, it is very, very wrong. That is why I tell people, don't put the bracket so that you will not be confused. Okay? We are trying to eliminate anything that will confuse you. So what do? You said 1 times the base, 1 times the base, plus 1 times the base again, plus 0 times the base, plus 1 times the base. What do you do now? Go to the power, 0, 1, 2, and 3. Are we together now? So the next thing you need to do is to do what? Evaluate this, this one, clear this one, clear this one, clear this one, clear this one, so you can have a common term. This is called 1 times 2 raised to power 3. Please take note. So many people make mistake of saying 2 raised to power 3 equals to 6. By their own understanding, what they do is what? 2 times 3 equals to 6. That is very, very wrong. 2 raised to power 3 means what? This is wrong. 2 raised to power 3 means what? 2 times 2 times 2. That is 2 into 3 places. If you have 4 raised to power 3 or 4 raised to power 2, it means equals to 4 times 4. That is what it means. Are you following? This is what it means. So in this instance, it's not going to be this. So what are you supposed to do? What you're supposed to do is very simple. Just put equals to what? 2 times 2 times 2 is equals to what? 8. So that means 8 should come here. 2 raised to the power 3 is what? 8. The next thing you're going to do is very simple, which is what? Plus 1 times 2 raised to the power 2 is what? 4. You put your 4 plus 0 times 2 raised to the power, this is what? 2. Plus 1 times 1. Okay? So what becomes, this time it becomes what? 8. Plus this time it becomes what? 4. Plus this time it becomes what? 0. You can cross it, but then let's follow up so you don't make mistake. This time it becomes what? 1. Okay, so after we should do what? Add everything together. This plus this is equals to what? 13. Please, this is not your final answer, but you are done. But the final answer becomes, for you to get your final answer, you must always reference to base what? 10. If you don't reference your base, you're just going to have maybe half mark because you just lost a mark by not labeling the base. You know, if you're writing junior WAEC, if you're writing WAEC, you need to also understand that they give award marks based on steps done. Okay, so you can't tell me after writing this you missed something here and you want me to give you your full mark. So what do? You must always reference your base after solving each number. So this is the first method you're going to use to solve this, especially in base 2. Let us solve for another number. So we have convert. Let's use convert. Let me use 2 to 1 base 3. 2 to 1 base 3 to base 10. What do? Please take note. The first thing you need to do is to do what? I say multiply this by this because it is what? Expansion notation. Multiply this by this, that gives you 2 times 3. You're done with this one. Move to the next digit. Plus, add your plus. This times this, 2 times 3. You're done with this. Move to the next digit, which is this times this, plus 1 times 3. After which, what do you do next? Put your powers 0, starting from the far right. This is the right, this is the left. Starting from the far right, come to the left. This becomes 1, this becomes 2. So this becomes 2 times 3 raised to the power 2 is not 3 times 2. Please, this is not the same thing. Okay, it is what? 3 times 3. Are we together? So what do you do from here? This becomes what? 9. That's 3 times 3 is 9. Plus 2 times, this becomes what? 3. Plus 1 times 1. What do you do next? This time this is what? 18. Plus this time this is what? 6. Plus this time this is what? 1. So after getting this, what do you do from here? This becomes, this plus this is what? 24 plus 1 is what? 25 base 10. Final answer. Now don't forget, I say you must put your base. You must represent your base to base this. So you must put your unit. That is the base. If you don't do that, you're not getting anything right. Now the next thing we're going to do is very simple, which is the other method I wanted to teach you. So you can be given a number such as, they say convert 1 base 2 to binary, to decimal, that is base 10. So what do? What happens here is that when you have the digits 1, 1, 1, 1, how many digits? 1, 2, 3, 4, right? So for each of this number in computer, we have that 1 represents on, 0 represents off. Let me put 0. So 0 is here, meaning 0 is here, right? When you have 1 in computing, it means true or 0, sorry, or on. But if you have 0, it means false or off. Now in this instance, what do? Now you take 2, because you're counting in base 2. 2 raised to the power what? 0. 2 raised to the power what? 1. 2 raised to the power what? 2. 2 raised to the power what? 3. So you see this one is off, this one is on. 2 raised to the power 3 is what? 8. This one is off, so I'm going to put 0 here. 2 raised to the power 1 is what? 2. 2 raised to the power 0 is what? 1. So you add this plus this plus this together. So this plus this plus this gives me what? Gives me what? 11. Thank you. Base 10. That's what it means. Because this plus this is 10 plus 1 is 11. Now let us use that expansion notation to see this. Now the expansion notation gives me 1 times 2 plus 1 times, 0 times 2 times 2 plus 1 times 2 plus 1 times 2. 0, 1, 2, 3. This becomes 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. This becomes 8 plus 0 plus 2 plus 1. So this plus this is 10 plus 1 is 11 base 10. Have you seen it now? The last thing I'm going to show you today is working with a number that has a decimal point. So if you have let's see 11.110 base 2 to base 10. Now when you have this, what do you do? This is the number in base 2, right? That is binary. Convert this to base 10. So what do you do? Please, you still do the expansion. Use expansion notation, please. In this instance, use expansion notation. So what do? When you see this, just like what we did in place value last time, in place value, whenever you see a point in a number, the place value changes, right? So if I have 248.729, the place value changes. This one becomes, this one, you don't do unit, tens, hundred. This is totally wrong. This is wrong. This is wrong. So what do you do? What do you do in this instance? The unit, because of the decimal point, it changes the formation, right? This one becomes the unit. This one becomes the tens. This one becomes the hundred, and you further through till you get to million and the rest, right? Now, from the decimal point, any number that comes after the decimal point becomes what? That is, if it's standing behind the decimal point, right? If you're standing behind the number, any number behind the decimal point becomes, from here you have tens, TH. That means the tenth you have here. Okay? This is what you have here. So the next one is 100. 100 HTH. Okay? The 100 TH. This one becomes the thousandth with the TH, right? So I'll put this thousand, now TH. This is what it means. You see, the formation changes. This one now is no more the same as this. The formation changes. The same thing happens in binary or in number system with any number that has to do with decimal value. Now what do? You still use expansion notation because you're converting from base 2 to, from any base to base 10. So the expansion notation says this one times the base plus 1 times the base plus 1 times the base plus 1 times the base plus 0 times the base. This one is this. This one is this. This one is this. This one is this. This one is now this, right? Okay. So how will I differentiate my decimal point? It's very simple. From this place is 0 and 1. You continue counting like that, right? So 2, 3, 4, 5, like that. But in this instance, you have 1 here. You have points. So this one becomes 1. So let's continue from where we stopped in our last class. So we have this equation already. Convert this 11.110 base 2 to base 10. So what are you supposed to do? Let's see. Solution. It's still the process, the same process we took before, but we're going to use here. Despite the point, right? So now when you see a point, what do? Please take note. Don't forget, whenever you're computing from any base 2, base 3, base 4, base 5, base 6, any base to base 10, you use what we call expansion notation, what we've been doing, right? So let us see how it works now. So we just multiply the number, each of the numbers by the base, right? Each of the numbers by the first thing, expansion notation. So we have 1 times the base plus 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 0 times the base. Now you don't do another thing. Apart from that one, please, this is just expansion. The next thing you need to do is to recognize the index values of these numbers. Okay? Now, don't forget that when we have something like 111, for example, base 2, we are expanding this is 0, 1, and 2, right? But because of this decimal point, it alters the formation. It changes the formation. I've said that before. It changes the formation to what? Now, any number that comes to the right hand side of this right hand side now, okay? This right side is the right hand side. Any number that comes here becomes a negative power. Now, any number that comes here remains the positive power. Okay? Now, when you're counting the negative power, don't forget that if you're counting the negative power, you start from -1, right? Okay? So we have -1, -2, -3. Generally, the mistake students make, they come here and write -3, -2, -1. Have you seen the difference? This is totally wrong. This is the mistake students make sometimes. Okay? Coming here to identify it as -3, no, you start from 1 and progress. Okay? Now, in this other side, you start from 0, because it is a positive number, right? This is a positive side, 0, and this is 1. you start from 0 and you go further to this other side. Okay? And if there was another number, so we put 3, 3, and the rest just continue like that. But since there's no other number, you just stop at 1, right? So what are you supposed to do now? So you come to this one. You don't put on the 0, the real numbers, right? You put on the base, please. So you describe the powers on the base. It is minus 3, minus 2, minus 1. 0 and 1. Okay? So what are you supposed to do next? Now listen. You work on the exponential first. So 1 times this raised to power 2 raised to power 1 is what? Is 2. Anything raised to power 1 is that same thing. Anything raised to power 1. I'm using the word anything because anything is anything. Okay, so if I have 1,000 raised to power 1, it is equals to 1,000. Okay? If I have x raised to power 1, it's equals to what? X. So 2 raised to power 1 is what? Is 2 plus 1 times 2 raised to power 0. 2 raised to power 0 is what? Is 1. Anything raised to power 0, take note, apart from 0. Any number raised to power 0, apart from 0, is what? Is 1. Is 1. So you put your plus. Now if this one comes down, times. Now coming to this, 2 minus 1. Oh, this is a negative power law of indices. So you can represent this. In indices, you have that a raised to power minus n is equals to what? Is equals to what? 1 all over a. This a comes here, n becomes the power here. N can be anything. A can be anything. So in this instance, a is this and n is this. Okay? So 2 raised to power becomes 1 all over 2. You can put this one. If you don't want to put the 1, you just leave it, let it be. Because anything raised to power 1 is that thing, right? So plus 1 comes here times 2 raised to power. This is 1 all over 2 raised to power 2 plus 0 times 1 2 raised to power 3. This one comes here, the base comes here. Isn't it happens here? So now let's work on this exponential here. We have 1 times 2 plus 1 times 1 plus 1 times 1 all over 2 raised to power 1 is what? 2 plus 1 times 1. 2 raised to power 1, 2 raised to power 2 is what? 4 plus 0 times. Please take note. 2 raised to power 2 is not 2 times 2. No, it is 2 into 2 places 1, 2. For example, if you have 3 raised to power 4, this means equals to 3 times 3 times 3 times 3. But oftentimes students make the mistake of saying 3 times 4. This is wrong. This is the correct thing. Don't forget that, please. So 1 all over, this becomes what? 2 times 2, that's 2 times 2 times 2. Don't forget 2 in the 3 places, giving us what? 8. So we should have 8 here. Okay, so what is the next thing I'm supposed to do now? I'm now work on the multiplicative value. Okay, so I have something very similar. So this 1 times 2 is what? 2 plus 1 times 1 is what? 1 plus 1 times the power, you can put all over 1, all over 1, and all over 1, this is nothing, you can just leave it. But then let's work, we are learning. So let's do it bit by bit, please. So 1 times 1 is 1, plus, comes down. 1 times 1 is 1, 1 times 2 is 2, plus 1 times 1 is 1, all over 1 times 4 is 4, plus 0 times 1 is 0, all over 1 times 8 is 8. Already this is gone, this is gone, because this cannot work. So this is gone. I will just cancel this one, it's nothing. Okay, let us eliminate it. Eliminate it, since you are learning, so let us learn. So this plus this is what? 3 plus. This divided by this is what? 1 all over, so the same thing. This divided by this just, I'm coming. So this divided by is 0, so plus 0. You see, you don't need the 0, so that's why I said you should just leave it 0, right? Just that one is 0, just let it be. So now I have this, and this. Now this is a real number, a whole number, so this is a fraction of a fraction number. So what am I supposed to do? I can work on this, get my answer, work on this. Going to stress me. So what am I supposed to do? Just put all over 1 here. Find the LCM of this, and this. So how do you find the LCM? You have 1 will not really affect anything. So you have 2 and 4. How do you find the LCM? Look at now, use the smallest part of this is what? 2. 2 goes into 2 is 1, 2 goes into 4 is what? 2. So you have 2 again. 2 goes into 2, 2 goes into 2 is 1. So you have 1. So 2 times 2 is what? 2 times 2 is equals to 4. Yes. Equals to 4. So we have 4 as our LCM. We have 4 as our LCM. What am I supposed to do next? Just simplify this to be this divided by this is 4. 4 times 3 is 12. Plus this divided by 2 is 2. 2 times 1 is 2. Plus 4 divided by 4 is 1. 1 times 1 is 1. So that gives me equals to Same thing you have between 1 and like this. Okay, you understand that the duration varies, so it can always give you instances of this what you do. You get the final this a number in base 10. This is the number in base what? In base 10. So this is what you do when you have a decimal number. But if you don't have a decimal number, you just walk through 0, 1, 2. I think the decimal point was not here. I didn't mean the decimal point was not there, so you just have here to be what? 0, 1, 2, 3, and 4. You evaluate to get your final answer, and that is the story. Okay, so let's see something else. Now let's see how to convert from base 10 to any base. Please listen. Let's see how to convert from base 10 to any base. Convert 60. Okay, let's use 60 base 10 to base 2, for instance. Okay, convert 60 base 10 to base 2. What do you do? Solution. Now, when you see something like this, what do? You don't use expansion notation again, because this one you're completing from base 10. That is the number of counting a number from base 10 to base 2. How do you do it? Now, you use a method called division method, right? You use your division method. So how do you do about that? 60. Just put a table like this, a table with 2 columns. Now, the column at the right, please, column at the right has 60, which is the given number, and the required base. This is the required base. This is the given base. This is the required base. So the required base will come here. Whether it is 4, 5, 6, 7, 8, 15, whatever thing it is, bring it here. Okay? Now this one comes to the right. This one goes to the left. Now what do you do? Now let's simplify this. 2 goes into 60. I don't know. What do you do? 6 goes in, 2 goes into 6. Can it go? Yes. So 2 goes into this is what? 3. 0 comes down. Simple method. So you don't have to kill yourself saying 2 cannot go into 60. No, take it bit by bit. This is how to eat the big elephant. Take it bit by bit. So we are done with this one. What is the remainder? In this format now you must keep your remainder. So what is the remainder? Remainder is 0, nothing is remaining. So 2 times 30 gives me 60 automatically. Now 2 goes into 15. You don't change this one, please maintain it. 2 goes into 30 is what? 2 goes into 30. I don't know. 2 goes into 3 is what? 1. What is remaining? 1. Look at, you have 30. 2 goes into 3. Sorry, 1, 2, 3. 2 goes into 3 is what? Look at, 2 goes here is 1. What is left? Is 1. So remember what? 1. Sorry. 2 goes into this is 1. Remember 1. You put the 1 here because I have 10, please. So 2 goes into 10 is what? 5. Remember what? 0. Nothing is remaining. So 2 times 15 is 30. I'm done with that one. Now 2 goes into 1. Cannot. So you carry this one and join it together. Now 2 goes into 15. If you have 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Count it. 2. Count in 2s here. 1, 2, 3, 4, 5, 6, 7. So 2 goes into this. How many times? 1, 2, 3, 4, 5, 6, 7. Remainder what? 1. So we have 7. Remainder 1. Now 2 goes into 7 is what? 2 goes into 7 is okay. Let's use it, right? So this is 6. This is 1, 2, 3, 4, 5, 6, 7. So what is left? That is 3. Remainder 1. 1 is left. Now 2 goes into 3. Let's use 3. 2 goes into 3. This is 1, 2, 3. Now 2 goes into 3 is 1. Remainder 1. So this becomes 2 goes into this is 1. Remainder 1. Now this method I told my children in the class is very simple. Whenever you get this, and now 2 goes into 1, cannot, right? Which is the last digit here. So 2 goes this should give me 0 because 2 cannot go into this. And I don't tell the number to add, just like what I did here. I don't tell the number to add to this to give me a bigger number, right? So 2 goes here, cannot. So what happens? This one that is here will come here and become remainder 1. Whether 6 is here, whether 3 is here, whether 4 is here in other bases, because 6 cannot be. 6 can be here, but then it can't be here. It can't be here because it's base 2. So, but if it is in base 7, 6 can be here. 6 can come here. Okay? So now when you're down here, what do? Just take this up, rule your line, okay? The vertical line from bottom to top. From bottom to top, and you call the numbers out. 1 from bottom, 2, 3, 4, 0, 0, base 2. So you see, this is the final answer. From this now, we've converted from base 10 to base 2. This is just the thing. Okay, can we prove it? Let us prove it using the abacus, paper abacus. We have 1, 2, 3, 4, 0, 0. This is in base 2, so it's very simple. So what do you do here? 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, 2 raised to the power 4, 2 raised to the power 5. This is, I'll write again. 2, this is 1, this is 2, this is 4, 2 raised to the power 4, 2 raised to the power 2 is 4, 2 raised to the power 3 is 8, 2 raised to the power 4 is 16, 2 raised to the power 5 is 8. So, right?
So you add the one that is 1. Anyway, you see 1, it means on in computing. In computing, it means on. When you see 0, it means it is off. So you don't reference those ones. So anyone you see 0, just cancel it. Anyone you see 1, add them together. So this becomes 32, 16, 8, and 4. This and this is 10. This and this is 10. That gives me what? 20. So you write what? 0, carry 2. This and this is 4 plus 2. This one was 6. So you see 6 base 10. 60 base 10, sorry. So that's just what you do. That's just what you do. And you get the final answer in base 2. So I'll write it again. 1, 1, 1, 1, 1, 1, 1, yes. 0, 0, 0, 0, base 2. And now answer. Is that clear? You can try with any other number. You can try with any number. So while you are watching this, try with 74 base 10 to base 2. Convert this to base 2. Convert this to base 2 while you are watching this. Okay? When you are done with that, you continue the class. So, let's see something else. How do we convert? That is converting from any other base to any other base. So let's see how to convert from one base to another, being not base 10 now, right? You're converting from any other base to any other base. Let's say you're converting from base 3, okay, to base 4. How do you convert from one base to another base? Not base 10. How do you convert? Now the first thing you need to do, listen. The first thing you need to do is when you're given a number, for example, you say convert 113. Should I use this? No. Okay. 11101 base 2 to base 3. Please take notes. Whatever thing I am doing here applies to any given base. Whether base 25, base 300, it applies the protocol, the standard, the steps remains the same. Please take notes. So when you are doing this, convert this to base 3. What do you do? The first thing you need to do, the first step is to do what? Convert this thing, convert this number to base 10. The first step is to do what? Because of my board, I'm trying to manage the board, so I can't write the steps, so you take note of the steps. Convert this base to base 10 first. After which, you convert from base 10 to base 3. I've taught you how to convert from any base to base 10. So you use what? Expansion notation to convert to base 10. After converting from base 10, after converting to base 10, now convert from base 10. I've taught you how to convert from base 10 to any base. So that is what you do using what? Division method. So let us see how it goes here. What do you do? Now when you see something like this, how do you go about it? It's very simple. Okay? Now solution. This becomes 1, right? There's no point. So if you don't do, you can say 0, 1, 2, 3, 4, and 5. 1 times the base. This is expansion notation, please. The first step you take is doing what? Converting this number using expansion notation to base 10. So 1 plus 1 times 2 is 1 times the base plus 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 0 times the base plus 1 times the base. 0, 1, 2, 3, 4, and 5. You see? So now this gives me a guide. So that let's say I wrote 6 here, for example, this is 6. It will not tell you what I have, so I have to go through it again. You see, it serves as a guide, so you need to do it. Just consider your time though. So this becomes 1 times 2 raised to the power 5. Please, 2 raised to the power 5 is not 2 times 5, but 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. That means 2 into 5 places. Don't forget that. So 2 into 5 places gives us what? 32. Plus 1 times 2 raised to the power 4 is 2 times 2 times 2 times 2 into 4 places. That gives us what? 16. Plus 1 times 2 raised to the power 3 is what? 2 times 2 times 2. That gives us what? 8. Plus 1 times 2 raised to the power 4 is, 2 raised to the power 2 is what? 4. Plus 0 times 2 raised to the power 1 is what? 2. Plus 1 times 2 raised to the power 0 is what? 1. You've gotten that. You've taken out. Now let us evaluate this. This times this is what? 32. Plus this times this is what? 16. Plus this times this is what? 8. Plus this times this is what? 4. Plus this times this is what? 0. Plus this times this is what? 1. And so what do I need to do next? Add all these convert this number to base 10. After which, what are you supposed to do? Convert from base 10 to base 3. And how do you convert from base 10 to base 3? I don't know. I'm trying to see if I can manage my board. So you write fast so I can clean. Okay. So this is the first answer, right? Answer number 1. So the answer number 2 now is the next thing you're going to do now. So you convert this number to base 3. Just come here and say 63. Sorry, 61. Please, I'm going to manage my board, please. (61) base 3. Whatever thing you say should come here. Whatever thing you have in base 10 should come here. So what are you supposed to do now? 3 goes into 61. How many times? Tell me now, how many times? So you can use a simple method that says 3 goes into 6. How many times? It's 2 times. 3 now cannot go into 1, so it's 0 here. Okay? So you put remainder what? Remainder 1. Simple. Okay? So 3 times 20 is what? 20 and 3. Take note. This goes here is 0. This goes here is 6. This gives you 60. If you add 1 to it, it becomes, that is plus 1. It becomes what? 61. So there's no magic in this thing. It's just you following the procedure. See, maths is the simplest subject, I know, because it has a laid down rules that do not change, except possibly you will be the next person to change it for us. But for now, we have a standard that even our great grandfather knew. It's still working till today. Unlike English, right? In English, everything changes almost every year. You see, you have different editions because you keep on adding words, you keep on referencing words and the rest. So let's continue, please. So we have 3 here. 3 goes into 2, cannot, right? So 3 goes into 20. What is small? Because it's the closest number to this 20 now, 3 can go into. Tell me now. It's 6. Because 6 times this is what? 18. 6 times 3 times 6 is 18. So that means remember what? 2. Now 3 goes into 6. How many times? 3 goes into 6. How many times? 2 times. Remember what? Remember 0. Now 3 goes into 2. Cannot. So it's 0. This 2 will come here. So remember what? 2. Right? So now you pick your point. I think you must always roll it from bottom to top. So from there now you now see that the answer becomes what? 2, 0, 2 base. Sorry. 2, 0, 2, 1 base 3. The base now will come here because we're converting to base 3. You converted from base 2 to base 10. From base 10, convert it to base 3. From base 10, convert it to base 3. That gives you the final answer. That gives you the final answer. It's not hard. It's not hard. And take note, when you're solving, after solving this, if your digit has containing number that is above the base, that means it is wrong. So I have to, don't forget that base 3 contains digits between 0 to 2. So that is what you have, and that is actually the correct thing to do. Any question? Before you solve, let us see some questions from our new concept mathematics, right? If you go to page 77, that is quantitative reasoning 5, right? There's some given questions for you to solve. So question number 5, I should explain some question number 5. Okay, question number 5 says convert 101 0 base 2 to, we have a box. This is a box. We have another box. And this is question mark in base 10. We put 10 here. Okay, we have another one here. And then we have base question mark, we have base 8. Okay? Now look at what I told you now. This is very simple. What do you do? Convert this thing from base 2 to base 10. From base 10, convert it to base 8. Very simple. So how do I convert this number to base 10? I can use the expansion notation that says 1 times the base plus 0 times the base plus 1 times the base plus 0 times the base plus 1 times the base plus 1 times the base plus 0 times the base. Okay? Now 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. I want to do something that is more funny. I'll just put 1 here. 2, 4, 8, 16, 82, 64. Look at this is 2 raised to the power 6, 2 raised to the power 5, 2 raised to the power 4, 2 raised to the power 3, 2 raised to the power 2, 2 raised to the power 1, 2 raised to the power 0. You can just do something like this. So you simply note that anyone that had 0 is off. Anyone that has 0 off. Anyone that has 0 is off. So the one that you're going to add is the one that has 1. Add this one. This will be added. This will be added. This will be added. So what are you going to add now? You add this one. Add this. Add this. Add this together. Right? So this plus this. This plus this is 20 plus 20 plus this is 80 plus 6 is what? 86. So we have 86 base 10. But let us use the other method to see whether it will give us this, right? So this becomes 1 times 2. This is the recognized method, please. If you're writing your, use this method. If you're writing any exam you see, use this method. But this one is faster and better objective. Okay, it is theory, it is the recognized method. So this is 1 times this plus 0 times the base plus 1 times the base plus 0 times the base plus 1 times the base plus 1 times the base plus 0 times the base. So since you have 0, 1, 2, 3, 4, 5, 6, what are you supposed to do? 0, 1, 2, 3, 4, 5, and 6. So this becomes what? 1 times. This becomes 2 times 2 times 2 times 2 times 2 times 2. 2 into 3, 6 places, sorry. So this becomes what? 64 plus 0 times, this becomes what? 32 plus 1 times, this becomes what? 16 plus 0 times, this becomes what? 8 plus 1 times, this becomes what? 4 plus 1 times, this becomes what? 2 plus 0 times, this becomes what? 1. What are you supposed to do next? See. Now multiply this, this means what? 64. This and this is 0, so it's gone. Plus this and this is what? 16. Plus this and this is 0, so it's gone. This and this is what? 4. This and this is what? Plus 2. Plus this and this is gone. 0. So you don't have to put it. Right? If you want to put, you can still put. Now this plus this is 20. 20 plus this is 80. 84, 86. So you have 86 base 10. Now you convert it to this becomes what? 86 base 10. Now convert from base 10 to base 8. That's what it means. Convert from base 10 to base 8. So now this becomes 86 to base 8. Don't forget, you always use division method. Whenever you convert it from base 10 to any base, use division method. So division method stays this, right? Just tabulate it in 2 columns. So this, the number you're converting to has the column to the right, while the base has the column to the left. So 8 goes into 8 is what? 1. 8 goes into 6 cannot, right? So you put 0 here. That is remainder 6. Because 8 times 10 is 80. 80 plus 6 gives you 86, right? Now 8 goes into 10. 8 goes into 10 is because 8 cannot go into 1 time. I made it together. 8 goes into 10 is what? 1 time. 8 goes into 10 1 time. Remainder what? Remainder 2. Okay? Now 8 goes into 1 cannot. So you put 0. The position still remain what? 1. So this one will come in. Just note that. Simply you just remember that this will always come in. Always remember that this will always come in. That's the best thing to do. So now you take your reading from bottom to top. This becomes 1, 1, 2, 6 base 8. So you come down to 1, 2, 6 base 8. Now use that same method and solve for the rest. Rephrase everything we've done. Use the same method and solve the remaining equations, right? Use the same method and solve for the remaining equations and submit it on Monday. If you have any question or any place you don't understand, please start that particular question. So when we come on Monday, we start from that one and we do our division. I would have done addition and subtraction of bases, but in my next video we will do addition, subtraction, multiplication and division of bases. Thank you very much.